All right, today we're going to tackle a huge, kind of mind bending question that sits right at the intersection of, well, poetry and physics. And that question is, what is the true relationship between time and energy? It's a connection we all feel intuitively, but what does science actually have to say about it?
You've probably heard some version of this idea before, right? Maybe you've even thought it yourself. Time is the medium that energy exists in. It feels right, doesn't it? It's this beautiful, poetic statement that seems to capture something really fundamental about our universe. But here's the big question for us today. Is that feeling actually based on scientific fact? Is this just beautiful poetry, or is it literal physics? We're going to put that statement under the microscope and see if it holds up. And to be totally fair, that intuition is pointing at something very real. The reason it feels so right is because, at its core, energy is the ability to create change. And you can't have change without time for it to happen in. Change can only be measured over a duration. So, for our first section, let's put on our strict, nitpicky physicist hats. We're going to look at the literal meaning of these words and build the case against the idea of time being a medium. Okay, first things first, let's be super precise. In physics, what is a medium? It's a substance. It's the stuff that a wave travels through. Sound waves need air, ocean waves need water. So if time is a medium, it has to be a kind of stuff. But is it? And physics gives a very clear nope on that one. Time isn't a substance, it's a dimension. Now, that difference is absolutely crucial. A medium is something you exist within, like a fish swimming in water. A dimension is a direction, something you measure along, like length or width or height. Here's a perfect way to think about it. Saying energy exists in time is kind of like saying height exists in a ruler. See how that doesn't make sense? A ruler is the tool we use to measure height, but the height isn't inside the ruler. It's the same thing here. Time is the dimension we use to measure the effects of energy. So, to a physicist, the word medium is just wrong for three main reasons. First, energy doesn't just exist in time, it exists on the whole stage of four-dimensional space-time. Second, energy itself isn't a stuff, like a fluid, it's a property of a system, basically a number we calculate. And third, this whole idea helps us avoid a famous old mistake in physics. For a long time, scientists thought light needed a substance called the ether to travel through. Turns out, nope. Einstein showed it wasn't necessary. And calling time a medium sounds a little too much like bringing the ether back. Okay. So the word medium is technically wrong. Case closed, right? Not even close. Because this is where things get really interesting. While the vocabulary might have been a little off, the intuition behind it points to one of the most profound and deepest connections in all of science. Seriously, that gut feeling we all have that time and energy are deeply fundamentally linked, it wasn't wrong at all. In fact, their relationship is an absolute cornerstone of how we understand the entire universe. So if time isn't a container for energy, what is the real nature of their connection? How are they so linked? Well, the answer comes from two of the most powerful pillars of modern physics. Get ready, because this is one of the most beautiful pieces of logic you'll ever hear. It comes from a brilliant mathematician named Emmy Noether. Step 1. We notice a basic fact about our universe. The laws of physics don't change from one moment to the next. Gravity works the same today as it did a billion years ago. We call this time translation symmetry. Step 2. Noether proved, mathematically, that for every single symmetry you find in nature, there must be a corresponding quantity that is conserved, that can't be created or destroyed. So what's the punchline? What quantity is conserved because the laws of physics are symmetric in time? You guessed it, it's energy. The law of conservation of energy is a direct consequence of the nature of time. They're basically two sides of the same coin. It's incredible. Okay, so that was the first big link. The second one comes from the wonderfully weird world of quantum mechanics. You've probably seen this famous little equation before, E equals hf. It just means that the energy of a quantum particle, like a photon of light, is directly tied to its frequency. So what does that really mean for us? Well, think about what frequency is. It's a measure of cycles per second. The per second part is key. You literally cannot have a vibration or an oscillation if you don't have time for it to happen in. I mean, if you could freeze a single instant, a moment with zero duration, nothing could vibrate. Frequency would be totally undefined. And if frequency is undefined, then according to that equation, so is energy. So in a very real sense, Time is the necessary canvas on which energy can even paint itself into existence. So, time's symmetry gives rise to the conservation of energy. And time's duration allows energy to even be defined. But we're not done, because Einstein's general relativity comes along and adds one more truly mind-bending layer to this whole relationship.
See, Einstein showed us that this isn't some one-way street where time just provides a stage for energy to do its thing. No, no. It's an active, dynamic relationship. It's a feedback loop where each one profoundly changes the other. Here's how this crazy feedback loop works. Step 1. Energy and mass exist in space-time. We've got that. But step 2, the very presence of all that energy and mass actually warps and bends the fabric of space-time itself. And step 3, this warping, specifically the way it stretches and slows down the flow of time, is what we feel as gravity. So they're not separate at all. Energy doesn't just exist on the stage of space-time, its presence actively reshapes the stage itself.
All right, we've looked at the arguments from classical physics, from quantum mechanics, and from relativity. It's time to bring it all together and deliver the final verdict on that poetic statement we started with. So, time is the medium that energy exists in. Is it true? Well, as a literal scientific statement, no, it's incorrect. Time is a dimension, a coordinate on a map. It's not a physical substance. But as a metaphor, oh, it's brilliant. It's incredibly insightful. It correctly senses that without time for change, without time for frequency, without time's deep symmetry, the very concept of energy as we know it would literally cease to exist.
So if we wanted to rephrase it to be both beautiful and scientifically accurate, maybe a better way to say it is this. Time is the dimension through which energy expresses itself. And that leaves us with one final staggering thought to chew on. If a huge amount of energy can warp and bend time, what in the world was time even like in the first tiny fractions of a second after the Big Bang, when all the energy of the entire universe was crushed into a single point? What does time even mean when it's being bent completely beyond recognition? That's something to think about.